This is Accelerated Geometry, Section 4.3, Triangle Inequalities. So the first thing we show is a drawbridge that goes over the Chicago River in Chicago. And the question is, how long must each side of this drawbridge be so that the bridge spans the river when both sides come down? Well, when they come down, they have to form a straight line. And so they have to be long enough to complete that side. If they're too short, the cars coming over it will crash into the river. If the two sides are too long, they will meet at a peak, and the cars also will not be able to get over this. So this is just a picture that kind of talks about what we're going to be doing today in class. Here are things called Tinker Toys. I don't know if they even make these anymore, but I know that that's what these are called. It says, why can you build this triangle with the green, red, and blue pieces? And why can't you build a triangle with one green and two yellow? Well, obviously, because the two yellow are too short to meet. They will never meet because they're too short. So what we're asking is, how long do those pieces have to be in order for me to create a triangle? So there is an investigation that we will be doing in class, investigation number 1 in section 4.3, which will lead us to conjecture 21. And then we're going to do investigation 2. And investigation 2 is going to lead us to conjecture number 22. So today, instead of doing those conjectures, I've decided to use Sketchpad. So the first conjecture that they want us to deal with is the sum of the lengths of any two sides of a triangle has what relationship to the length of the third side. So they made this the third side, so that's 7.67. These two sides are measurements of 4.98 and 4.27. They add up to be, so M and N together add up to be 9.25. If I'm going to have a triangle, look what has to happen. The sum of the measures of these two sides has to be always greater than this side. If I bring it down, when they're equal, I don't have a triangle at all. If the sum would be less than, those two sides wouldn't even meet. So here at least they're meeting, but they're meeting on a straight line. Okay? In order for me to have a triangle, there has to be some lift here. And when I create the lift, M and N added together are always going to be greater than the length of this. So if this is the drawbridge, or if this is the roadway, and these two pieces are the drawbridge, in order for them to create the road, they have to be straight. If I want to make a triangle out of them so that the cars would have to go up and then down, which would not be great, but if I had to create that triangle shape, those two lengths, M and N, added together have to be greater than the length of the third side. So this is the conjecture that goes with that. And the conjecture number for that is, I'm looking here, number 21. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. And at the end, I'll show these to you again. Okay, so I will now look at the next part of this. The next part says, what is the relationship between the angles and the sides in a triangle? So I'm going to get rid of this sum. I don't care about that anymore. And I'm going to bring these angles over. So BCA is here, ABC is here, and BAC is there. Okay, so now I have these all situated nicely. I'm going to look at the biggest angle. Now I'm going to look at the three sides. The three sides are 4.31, 3.86, and 7.67. The side opposite from the angle that is 140 is 7.67. Okay, so the biggest angle and the biggest side are across from each other. Okay, let's look at the smallest angle. So the smallest angle is 19 degrees, and I look at the three sides. I'm going to knock out these two because they're not the smallest. This is the smallest. So the smallest angle is across from the smallest side. And now if I look at the medium-sized angle, that's that guy. Across from him is the medium-sized side. This one's too smaller and this one is larger. So I'm going to knock those out. I'm going to say the medium-sized angle is across from the medium side. Okay, this is how they say it. In a triangle, the longest side is opposite the angle with the greatest measure, and the shortest side is opposite the angle with the least measure. So we're going to kind of rewrite that again at the end when I show you conjecture number 22's form that is on our conjecture list. Okay, there's one other investigation in the lesson today. In order to do this one, I'm going to bring back this slide, and I'm going to go over here. We need a little bit of vocabulary. So inside the triangle are interior angles. Interior, interior, interior. There are three interior inside angles. If I extend one of the sides, there is another angle created that's not 180 degrees, not this guy here, but this angle in here that's less than 180 degrees. It's on the outside of the triangle. It's formed by a side of the triangle and an extension of the side. Okay, so there are other exterior angles. I could extend this side, and then I would have another exterior angle. I could extend this side, I have another exterior angle. So now some people would say, how come I didn't extend this side? Wouldn't that give me an exterior angle also? Yes, it would. It would be over here, and those would be vertical angles, which would be identical in measurement. So that doesn't matter which side you extend, they're going to be equal. Okay, so now that we know we have interior angles and exterior angles, if I'm sitting in this exterior angle, next to me, adjacent to me, is this interior angle. So this is called an adjacent interior angle. These two interior angles are far away from me. They're remote from me. So those are called remote interior angles. What they want us to investigate today is what's the relationship between an exterior angle and its two remote interior angles. So to do that, I'll go back to Sketchpad. And here is triangle ABC. We extended this side AB so that it goes out here with a D on it. And an exterior angle is formed right in here. And we measure it. So this is the measure of this exterior angle, CBD. Okay, then what if I measure CAB, which would be right over here, and ACB, which would be over here? Then I take those two angles, which are remote interior angles. If this is the exterior angle, this is the angle adjacent to it, the interior adjacent, but these are the remote, far away from this exterior angle, yet still inside the triangle. So these would be remote interior angles. So now if I look at the sum of these two remote interior angles up here, there they are added together, and I compare it to the exterior angle, you see that they are the same. Now what if I move this? Here's the exterior angle, here's the sum of the two remote interior angles. So it does not matter where I move these, they're still going to have that relationship. So the measure of an exterior angle of a triangle equals the sum of the measures of the remote interior angles. So now I'm going back to the presentation, and I'm going to go over here. So here are the conjectures that we came up with today. Conjecture number 21, the sum of the lengths of any two sides of a triangle is greater than the length of the third side. And here is a picture that goes along with it. in one triangle, this doesn't work if I have three triangles all connected together or two triangles connected together. In one triangle, the shortest side is always opposite from the smallest angle, the medium side is opposite from the medium angle, and the longest side is opposite from the largest angle. And I tried to show that here. So 50, let's start with the smallest one. So 7 inches is across from the smallest angle of 51. The medium-sized side is across from the medium angle of 54. And the largest side of 9 inches is across from the largest angle of 75. And then conjecture number 23, the measure of this exterior angle, angle number 3, is equal to the sum of the measures of its two remote interior angles 1 and 2. So those are the conjectures in today's lesson. And I felt that using Sketchpad was a pretty decent way to show you how those conjectures work.